Hello class, this is lesson 4-1 about graphing linear functions. And just to remind you, a linear function is a function whose graph is a straight line, okay? There are two ways that we're going to practice this in this lesson. The first is simply to make a table to graph our line. So we're going to have a collection of points and we'll connect those points with a ruler. The second way is to just graph the x and the y intercept, and then you connect those 2 points. To start, we're going to pick 5 x values because I like plotting 5 points. So typically we're going to pick -2, -1, 0, 1, and 2 as our x values to plug in, and then we'll find out what their y value is. So when I plug in -2, that's really -4 minus 1, which is -5. When I plug in -1, that's -2 minus 1, which is -3. When I plug in 0, that's 0 minus 1, which is -1. 2 times 1 is 2, minus 1 is 1, and then 2 times 2 is 4, take away 1 is 3. So now I can go ahead and plot all 5 of these points on my graph, and hopefully they're going to line up to create a straight line. So I'm going to go ahead and label my graph. I'm just counting by ones, and so I'm going to have -2 all the way down to -5, and then -1 down to -3, 0 down to -1, 1 up 1, and 2 up 3. And look at that. It does look like they are all forming a straight line. So I'm going to take my ruler and I'm going to draw a line all the way through my graph, and I'm done. So that's all that we're going to do today. So let's do this again. I'm going to use the same 5 points, -2, -1, 0, 1, and 2. So -2 is +2 plus 3 is 5. -1 is +1 plus 3 is 4. And then 0 plus 3 is 3. -1 plus 3 is 2. And -2 plus 3 is 1. So there we go. I have my 5 points. Let's go ahead and label our graph. I can still just kind of count by ones for each little increment there. And let's plot these. So I have -2 all the way up to 5, -1 up to 4, 0 up to 3, 1 up to 2, and 2 up 1. And it looks like they are forming a straight line, so let's connect it with our ruler and then draw our arrows on both sides, and we are done. Okay, let's move on to a couple more. This time the equation is y is equal to 3x minus 4. And again, let's use the same 5 points, -2, -1, 0, 1, and 2. So that's -6 minus 4, which is -10. Next is -3 minus 4, which is -7. And then I have 0 minus 4, which is -4. 3 minus 4 is -1. And 6 minus 4 is +2. All right, I'm going to go ahead and label my graph quickly, and then I can plot all 5 of my points. Since I need to go all the way to -10, I'm going to count by 2's on my y-axis instead of just counting by 1's. So I have -2 all the way down to -10, and then -1 down to -7, 0 down to -4, 1 down to -1, and then 2 up 2. And then I can connect my 5 points, and it makes a straight line. Awesome. All right, last one is y is equal to 1/2 x minus 1. And since I'm multiplying my x's by 1/2, I'm going to pick even numbers so that I don't have to deal with any decimals. So let's go ahead and plug these in. 1/2 times -4 is -2, minus 1 is -3. 1/2 times -2 is -1, take away 1 is -2. And then when I plug in 0, that's -1, which is -1. 1/2 times 2 is 1, take away 1 is 0. And then 1/2 of 4 is 2, minus 1 is 1. So let's go ahead and label our graph now. And then I can go ahead and plot all 5 of these points. So -4 down -3. -2 down -2, 0 down -1, 2 at 0, and then 4 up 1. and I can see that they all form a straight line, and I'm done. Okay, let's move on now. I have y is equal to 3. There's no x variable, so that just means whatever x number I pick, the y is always going to equal 3. So I could just pick some random numbers for my x's, like -4, -1.5, 0, 2.5, and 3, just random numbers. And I'm going to go ahead and label my graph, and you'll just see what this looks like. So here we go. -4 up 3, -1.5 up 3, 0 up 3, 2.5 up 3, and 3 up 3. I can connect all 5 of those points, and look at that. They all form a horizontal line. So what I want you to notice is whenever it just says y is equal to a number, it's always going to be a horizontal line that is crossing the y-axis at whatever that number is. So for instance, this time it's crossing at 3 on the y-axis. All right, our next one says x is equal to -2. So that means every single x is going to be -2, and the y can be whatever you want because there is no y variable in my equation. So I'll just pick some random numbers, and then I can go ahead and label my graph, and I can plot all 5 of those points. And you're probably predicting what this is going to look like already. So I have -2 down to -3, -1, -2 at 0, -2 up a half, and -2 up 2. And they are forming a vertical line. So whenever you have x is equal to a number, it's going to look like a vertical line that is crossing the x-axis at that number. In this case, it's crossing at -2. Okay. So why don't we go ahead now and move on to our second method, which is graphing using intercepts. And we're talking about the x-intercept and the y-intercept, which, looking at a line, is the location where your line is crossing either the x-axis or the y-axis. And this is going to be another way that we can very quickly graph linear equations. So I'm going to go ahead and draw for you a line, and I'm going to have my 2 points there and draw my line. And so you can just look at it. It is crossing the x-axis right there at -3, 0. And that's called the x-intercept. Okay. And then the y-intercept is down below. We can see that it is crossing the y-axis at 0, -2, which means that the y-intercept is located right there. If I was going to write these out, I would say the x-intercept is equal to just -3. I'm not going to write the entire point. And the y-intercept is equal to -2. All right, so let's go ahead and put this together. So sometimes we have to find them ourselves. And what we're going to do is we're going to take this equation one step at a time. I'm going to rewrite the equation. And to find the x-intercept, I'm going to plug in 0 where the y is. So this is going to be -3 times 0, which really just crosses that out. And I'm left with 2x is equal to 6. I can divide both sides by 2, and this tells me that the x-intercept is going to be at +3. Okay, let's kind of do the same thing now to find the y-intercept. So I'm going to just rewrite my equation. 2x minus 3y is equal to 6. And this time I'm going to put a 0 where the x variable is. And that leaves me with -3y is equal to 6. And when I divide both sides by -3, I find that the y-intercept is equal to -2. So now that I have both of these, it would be very easy for me to graph it. Okay, so let's put this skill to use now to actually graph a line. So I'm going to graph x minus 2y is equal to 2 using intercepts. So I'm going to rewrite my equation to find the x-intercept. So x minus 2 times 0 is equal to 2. And I find that just the x-intercept is equal to 2. So that was pretty easy to find. I'm going to put a 2 on the x-axis, and now I'm going to move on to the y-intercept. So this time I'm going to replace the x with a 0, and that leaves me with negative 2y is equal to 2. I can divide both sides by negative 2, and the y-intercept is found at negative 1. So that means I'm going to plot a point at negative 1 on the y-axis. I have my 2 points. I can just draw my line, and I'm done. Look at that. Piece of cake. Okay, so let's do this one more time, and then we'll be done. Our equation is negative 3x plus 4y is equal to 12. So again, let's start by finding the x-axis. Let's replace the y variable with the number 0. So I'm left with negative 3x is equal to 12. Divide both sides by negative 3, and x is equal to negative 4. So that's the x-intercept, which means on the x-axis, I'm going to put a dot at negative 4. Okay, let's rewrite our equation one more time. Negative 3x plus 4y is equal to 12. I'm going to replace the x variable with a 0. That leaves me with 4y is equal to 12. Divide both sides by 4, and I find the y-intercept is equal to positive 3. So that means up above at 3, I will put a point, and I can connect my dots to form my line. And that's it. So hopefully this new method makes sense to you, and we will do some practice when we get into class.